Hey guys, welcome back. Today we are gonna discuss about the techniques of proof. We all face problem like proof statement, theorems, numerical statement or such more in maths. But we don't know how to begin the proof, so we always stick at the same problem. But don't worry from today. We will never confuse on such problem. Watch till the end of this video to gain the techniques of proof. In mathematics, proving a statement or theorem typically involves using a logical sequence of steps to show that the statement follows from previously established results, definitions, and axioms. Now let's see some common techniques of proving mathematical statement or theorem with some examples. Here are some common techniques. 1. Direct proof. 2. Proof by contradiction. 3. Proof by induction. 4. Proof by contrapositive. 5. Proof by exhaustion. 6. Proof by construction. 7. Proof by counterexample. Number 1. Direct proof. In a direct proof, we start with the given assumptions and use logical steps to arrive at the statement we want to prove. For example, to prove that the sum of two even numbers is even, we can start by letting the even numbers be 2a and to b, then we can show that 2a plus to b equals to a plus b, which is also even. Here a b is any integer. Number 2. Proof by contradiction. This technique involves assuming the opposite of what we want to prove, showing that this assumption leads to a contradiction, and thus concluding that the original statement must be true. For example, to prove that root 2 is irrational, we assume that root 2 is rational and can be expressed as a fraction in lowest terms, and we need to show that this assumption leads to a contradiction. Let's see how it works by proving the statement root 2 is irrational. First, assume root 2 is rational. Secondly, if root 2 is rational, then root 2 equals a by b, where a, b belongs to set of integers, and a and b are coprime, also b not equals to 0. This implies to equals a square by b square. This implies to b square equals a square, then a square is even. If a square is even, then a is also even, so a equals to k, for any k belongs to set of integers. Substitute a equals to times k back into the equation, to times b square equals a square. Implies to b square equals to k whole square. Implies b square equals to k square. This gives that b square is also an even number. Therefore, b must also be even. Since both a and b are even, they have a common factor of 2, which contradicts our original assumption that a and b are coprime. That means they have no common factors other than 1. Because our assumption root 2 is rational leads to contradiction, we conclude that root 2 is irrational, hence proved. Number 3. Proof by induction. This technique is often used to prove statements about integers. It involves 2 steps: the base case, where we prove the statement for the first integer, usually 0 or 1, and the inductive step, where we assume the statement for an arbitrary integer k, and then prove it for k plus 1. If both steps are successful, the statement holds for all integers. For example, sum of n terms of the natural number is equal to n times n plus 1 by 2. It can be proved by this method of induction. Then let's prove it. First, our given statement is 1 plus 2 plus 3 plus 4 plus ... so on ... up to n terms equals n times n plus 1 by 2. Let's name this as equation 1, according to induction method. For n equals 1, the given statement is true. Next, let the statement is true for n equals k, that is 1 to plus 3 plus ... plus up to k equals k times k plus 1 by 2. Let's name this as equation number 2. Here k is any positive integer. Now we need to prove that the given statement is also true for n equals k plus 1. Let n equals k plus 1, then the statement will be 1 plus 2 plus 3 plus ... plus k plus 1. This is equals to k times k plus 1 by 2 plus k plus 1 from equation number 2. By addition rule of fraction, k times k plus 1 by 2 plus k plus 1 equals k times k plus 1 plus 2 times k plus 1 whole divided by 2. Here k plus 1 is a common factor of the numerator terms, and so that becomes k plus 1 into k plus 2 divided by 2. which imply that 1 to plus 3 plus dot dot. Plus k plus 1 equals k plus 1 into k plus 2 divided by 2, which also equals to k plus 1 into k plus 1 divided by 2, which imply the given statement. Hence, whenever the given statement is true for any positive integer k, then it also true for k plus 1. Hence, it is proved. These are some common techniques of proof which I have discussed now. I think you'll have now understood these concepts of proof. If you want explanation of remaining methods of proof too, then comment below. Also do subscribe our channel and stay tuned with us for more video like this. Keep studying, keep exploring and enjoy learning. Thank you so much. See you soon.